Hi, everyone. Welcome to Brain Talks. I'm Deborah Kahn, founder of Being Patient. Today, we're going to talk about a topic a lot of us know is good for us, but we don't necessarily know why, and that is exercise. Joining us now is Dr. Wendy Suzuki. She's a neuroscientist from New York University, and she's dedicated much of her research to understanding how exercise impacts our brains. And we're very glad to have her with us today. Thanks so much, Wendy, for joining us.
Oh, it's a pleasure to be here.
Okay, I want to just really get into it because, we were talking before, and I know exercise to me is part of my daily routine. I need to go on my morning run. Otherwise, I don't feel very well. But what exactly do we know as what's happening in our brains when we do exercise?
Yeah. So here's what happens when you go on your morning run. Exercise, there are immediate effects on the brain. And the immediate thing that it's doing is it's changing the neurochemical bath that your brain is bathing in. I like to call it a neurochemical bubble bath that you are creating with exercise, because it is increasing positive things like serotonin and dopamine that are making you feel good, that good mood feeling neurotransmitters, noradrenaline that's helping your memory, endorphins, which is the brain's endogenous morphine that is helping you withstand the pain that you might be feeling from the run, because there is stress on your body as you run. And in the long term, what you're getting is, there's more immediate effects. The other immediate effect, what happens right after you run, is that your prefrontal cortex right behind your forehead is frankly working better. Prefrontal cortex is essential for what we call executive functions, ordering things, your focus, your attention. It's involved in decision making. Those things work better. We're not exactly sure why. It's probably some of the growth factors that are being enhanced with exercise. The other thing that gets enhanced is your reaction times. You're actually responding generally better and faster to different things. So those are all the immediate effects that everybody can benefit from. And this is typically the maximum benefit comes from your mid-level exercise, whatever, not one that pushes you, that you're so sore that you can't move the next day, but one that you feel really good after. And so, yeah.
Yeah, it did occur to me though, is this, we know regular exercise is essential to maintaining brain health, but are there long-term positive effects of an exercise routine? So for example, I went for a run this morning. Am I making my brain more healthy, down the line? Does it have a lasting impact?
Yeah, that's a great question. And in fact, that is probably the most important effect of physical aerobic exercise. Physical exercise, actually, it's both aerobic, and there's some evidence that non-aerobic resistance training is also beneficial. That is changing the brain's anatomy, physiology, and function. As you continue to exercise, as you change your cardiorespiratory fitness, as your regular physical fitness goes up, your brain strength goes up at the same time. Why? Because of that neurochemical bath. The more you keep those good neurochemicals that include growth factors that are helping new synapses to form. The other exciting thing that people don't realize is that those growth factors are actually stimulating the birth of brand new brain cells in a key brain area that I've studied for the last 25 years called the hippocampus. Critical for long-term memory. So you can imagine the brain kind of like a muscle. The more you exercise, the more growth factors you have, the more bubble bath kind of inducing chemicals you make. And the bigger your hippocampus is, because if you have more cells, the bigger your prefrontal cortex is, because you have more synapses up there, and the axons get, they work better because they have more insulation around them. You are literally resculpting your brain with exercise.
Is there an age, though, that we lose the ability to add brain cells, or as long as we're exercising and treating our brains well, or our bodies, I should say, well, and therefore impacting our brain. Is there an age really where that just stops because we're getting older and everything's starting to decline?
Absolutely not. And the great news is that studies have shown that even older people, 75 and over, that have been diagnosed with Alzheimer's dementia, they can benefit from a 3-month exercise regimen. So increase their exercise, and you see the effect on their daily dementia score. Everybody else that didn't get exercise, their dementia score is going up and up and up, higher and higher levels of dementia. Again, these are older people that have already been diagnosed. If you go on your exercise regime, their dementia score actually decreased. That says to me that you're never too old to benefit. You also asked me specifically about neurogenesis. Is there an age where that drops off? Well, lots of evidence suggests that the older you are, the less neurogenesis that you have. But that study that I just quoted says that maybe, neurogenesis isn't every part of the explanation, that you can still benefit even if you're over 75 and may have very little neurogenesis. Why? Because you're still stimulating all those good neurochemicals every single time you exercise.
So just give us a little bit of background on the development of the brain. I know, especially the frontal cortex area, we're developing it up until we're about 25 years old, it's growing. Is that right?
Yeah, that's correct. The prefrontal cortex is one of the last developing areas of the brain, which explains, why an 8-year-old is not the same as a 35-year-old. The major difference is the development of the prefrontal cortex. And
they also say that also explains why teenagers make such bad decisions, because that part of the brain is still growing.
It's still growing. They're still learning. There's still hope for, all those perhaps bad decisions when you're 16, they all resolve. Or at least they get better with more development. So yes, it's one of the last developing brain areas. Absolutely.
So what does it mean exactly when you say we're adding or making new brain cells? Does that mean those areas are becoming bigger, or what does that mean in layman's terms?
Yeah. So what that means is for hippocampal neurogenesis, you are actually you're birthing new brain cells in that part of the brain. Now, is it enough to, double the size of your brain? Absolutely not. It's a modest number of new brain cells. But they've shown in studies in animal model systems that those brand new brain cells that get stimulated by exercise are actually, they're kind of like, I call them teenager neurons, because they're very active and they like to get involved in lots of new memory circuits that the hippocampus is very, very involved in. So yes, it is at least in the hippocampus, it is the creation of a new brain cell that hadn't been there before. That is what your exercise is stimulating.
Okay, and we're getting some questions now from members of our audience. And this question comes up a lot, which is, how much exercise do we really need in order to improve our brain health, number one? And do we have to get to a certain threshold in order to reap these benefits?
Yeah. So you asked me what the new frontier of my research is, and that new frontier is answering very precisely that question. Now, let me answer it with the data that we have from the literature right now. And the data that we have is that regular walking can reduce your chances of getting dementia by about 30%. That's nothing to sneeze at, right? Just regular
significant amount.
Walking, okay? But another exciting study that was just published last year in Swedish women looked at, it was a 44-year follow-up study. And when these women were middle-aged in their 40s, back in 1969, they were asked whether they were low fit, mid fit, or high fit. They were measured, and they were determined to be low fit, mid fit, and high fit. Then they could go off and do whatever they wanted for 44 years. And later they asked, what happened to these women that were low fit, mid fit, and high fit? And if you were high fit, you were 90% less likely to have developed dementia. That tells me that we're dealing with in the range of exercise that's attainable. These are not Olympic athletes here. We can change and modify our probability of getting dementia by between 30% with walking and 90% with being a high fit person. Okay.
So that's a significant amount. And we know that when we exercise, we fire off endorphins, right? And so what is the exact relationship between endorphins in our brain, or do we know yet?
Well, that's a good question. So endorphins are the brain's natural morphine. So it's a painkiller for the brain. There was a big controversy over whether brain-derived endorphins were the underlying the runner's high that all the press reported, and in fact, it turns out to be true that endorphins underlie the runner's high. That's not everything. I mean, that's a feel-good kind of response, but serotonin and dopamine are also going up with every single exercise bout. So that's also certainly contributing to your good mood. Those things alone are not protecting your brain necessarily. They are, it's really the growth factors that I think are playing a key role. In particular, brain-derived neurotrophic factor. People might have heard of BDNF. Very important one that we know the most about in neuroscience, but there's also a whole wide range of other growth factors that we think are very important as well.
So BDNF is exactly what? What is that? Is that growth factors meaning adding brain cells? Is that in layman's terms?
So growth factors are molecules that basically they help in development when you're a baby and all the neurons are forming for the first time. But in adulthood, these growth factors help new synapses to form, new connections to form. And BDNF in particular is essential in your hippocampus to help and create this new brain cells to be born, the neurogenesis in the hippocampus. You absolutely need BDNF.
So, Wendy, tell me, I mean, it sounds like we know a lot more, and our knowledge of the brain and how it relates to exercise is certainly increasing. But what is it that we don't know now that we should know, or where research may, should head in?
Yeah. So what we need to know is what everybody asks me at the end of every talk, which is just tell me exactly what I need to do. I don't want to know what the Swedish woman did or the other people did. I'm me. And so what I'm getting to is personalized recommendations, optimizing cognitive performance for an individual. And so that's what the research in my lab is getting at. So how can we individualize these responses for you at your gender, at your age, at your fitness level, for your level of running right now? First, what is that doing for your brain? You already have stated very clearly that you see a clear difference. But let's quantify that. Let's put that to the test. Let's use cognitive standardized tests to manipulate that and see whether we can get it better. Maybe a little longer run would do something different. Maybe a little shorter or more intense run. This allows us and allows me as a researcher to start to explore the precise kind of exercise, including novel exercises that you might not have done, but stimulate your brain in a new way, because we all like to do the exercises that we're really, really good at, but new exercises that stimulate us and really force us to use our coordination in a new way are also very, very powerful to enhance brain function and may also maximally enhance our cognition as well.
You had told me how you engaged some of your students in exercise. I want you to share that story because I think it's a really great story.
Sure. So I had gained 25 pounds and just focusing on work too much, not moving at all. And I decided to go to the gym. That was my wake-up call, or at least part of my wake-up call. I needed to lose 25 pounds, change my diet, but my main difference was I changed my regular physical activity. And I noticed a huge difference. First in my mood, that was absolutely clear. But then I noticed how much it changed my memory. depended on the hippocampus, and my focus depended on the prefrontal cortex. And that's what got me fascinated with this that's the area of research. And to learn a new area, the best way for a professor to learn a new area is to teach a new class. So I'm an undergraduate teacher, so I developed a new class called Can Exercise Change the Brain? And because it was inspired by me going to the gym, I decided I wanted to bring exercise into the classroom. So make all the students exercise. I would exercise with them, and then I would teach them about what exercise was doing to their brain. But when my administration didn't have any funds to pay for an exercise instructor, I decided to go become an exercise instructor myself so I could actually teach the class myself. And to their credit, my university paid for my teacher training because I was doing it all for the students. And so I went and I got my teacher training. I practiced for 6 months straight to learn how to do this because I was a great student in the class, but it's very different to actually lead a class. And so I did that, and I was very nervous the very first day I did this workout, and but it completely changed my research life. It became the focus of my research life because I saw how much this exercise transformed the classroom. It changed my teaching because it kind of upped my level of engagement, and it really, I think it was very, very memorable for the students as well to be sweating with their professor. So it was a great experience all around.
Absolutely. Let me throw this question in a different light, which is, so for example, last night I had a conference call in the middle of my night here, and I was up for a good 4 hours during the night. And I woke up this morning feeling like, I had that really bad, like no sleep hangover, so to speak.
Yeah.
And I knew that if I didn't run today, I would be a disaster, which is counterintuitive because when you're exhausted, you don't think, oh, well, maybe I shouldn't go for a run. I should save my energy. But I feel like there's a connection there. When I have a bad night's sleep, if I go for a run, it actually improves my performance during the day. How do you explain that?
So, I mean, it's a balance. I mean, there's certainly long enough sleep deprivation where maybe it might have been better for you to sleep in and not do that. But you are obviously experimenting with yourself, and you're finding that point where, yes, if I do drag myself out and go for the run, then by the end I do feel better and I'm able to function better that day. Both of these things that we've identified here, physical activity and sleep, are both essential, really essential for optimum cognitive performance. And both of them are malleable. You can change your exercise routine. You can really put some hard and fast rules that I know a lot of us don't do around sleep time. No screens near bedtime. That is terrible. Do not look at your phone. Do not look at your iPad. Don't even watch Netflix. Sorry, can't do that. Because it is clear that good sleep is essential for your brain. And what I love about exercise is that you not only get the benefits of exercise, all of these neurochemicals, these growth factors that are going up every time, but exercise will then help your sleep the next night. So it's kind of a double whammy of exercise, addressing two of the key things that we know is essential for optimum cognitive health.
Okay, and we get this question all the time. People say, well, what type of exercise? Would you say we're moving down to, I mean, it really depends on the person and what works. You have to find out what works for yourself.
Yes.
And part of it has to be aerobic or no? Or we don't?
So we know the most about the effects of aerobic activity. And yes, aerobic activity that gets your heart rate up is great. And the easiest, actually, literally today, I was researching the most common forms of exercise that women do across the globe. And in the United States, the most common form of exercise is walking. And that's fine because walking is aerobic. even particularly a low fit person. That's the easiest way you can start to get your heart rate up, is just go for a good, good solid walk. So you could always start there. That's free. Add one set of stairs, you up your aerobics right there. There is growing evidence that resistance training is also good. People, including my lab, are starting to compare and contrast high intensity interval training with continuous aerobic exercise with walking versus sitting. We know, I think, a lot more about high intensity interval training on muscles and heart, not as much on brain. So I think that's a really interesting area of study. But what I recommend most is move your body in any way that you enjoy and that you can do on a regular basis. And for everybody, I don't care who you are, for me, the best way to move your body is walking. I mean, of course, I live in New York, so I have to walk a lot. But there's no dressing up in your expensive Lululemon. It's just walking outside. And we know that has an effect on long-term brain health, decreasing chances of dementia. So that's always the easiest answer.
And you picked a exercise routine. I think it's called Intensati, is it? And it's
Intensati, yes.
That's right. And that's a very unusual routine. Why did you pick that?
Well, so the story goes, I was still pretty new at the gym, and I was really excited, and I was becoming a real gym rat. And one night I went into the gym, and there was a choice at 6 o'clock. I could take one of two classes: cardio boot camp or Intensati. And cardio boot camp just sounded too hard. It's like, I'm not going to that. I'm going to this other one. I don't know what it is, but it has to be easier than cardio boot camp. It wasn't easier. So Intensati was developed by this amazing fitness instructor. Her name is Patricia Moreno. And what it is, so first, what it means. Inten comes from the word intention, and sati is a Pali word that means mindfulness or awareness. So the practice of Intensati is a practice of bringing a whole new level of mindfulness to your own intentions. What do you want to do? What do you want to get out of this workout? It's already reminding you to feel and get into your body. But the workout itself is combining movements from kickbox and dance and yoga and martial arts with positive spoken affirmations, so that each move has a different affirmation. Affirmation like, I am strong. I believe I will succeed. I am powerful. I am inspired. And so you string these moves and these affirmations together in what's called a series. And so then you get a whole bunch of sweaty affirmation shouting people. And while newbies to the class, and I know from a particular experience, feel idiotic the first time, once you get over that, you realize that the shouting is increasing the cardio output. It's increasing the strength of that workout. And you cannot feel bad if you shout, I'm strong, together with a whole bunch of other people for a whole hour. It's just impossible.
Well, I have to say, I was lucky enough to attend one of your classes at a conference, and it is, I mean, you leave feeling great. It's you feel mentally great and physically great.
You do, and you feel connected to the class, and you feel connected to each other. And that was the class that really got me so regular. I was like, I couldn't wait to go back to this class. And that's the class that I trained to be a teacher for when I wanted to bring it back into the classroom. So I love that.
So Wendy, you talked, just to wrap it up here, you talked a little bit about your research in terms of determining what different types of exercise impacts the brain and the benefits of that. But where are you going with all of this? Like, if you solve that part of the equation, are we done, or where do you see your research going in the next decade?
Yeah, that's great. That's a great question. So step number one, optimized individual cognitive performance. What workouts that you do, and that's part of it as well. I want to move out of the kind of scientific randomized control study pattern where you have to do what I say. I choose spinning, so you all have to spin. I want to be able to pay more attention to what you like to do. Maybe you hate spinning and you love running, so you run. But then explore other things around running that you're able to do, and create your own exercise program based on that. That will maximize your brain functions. And step number 2 is image your brain. When we found what optimizes your brain, let's see what's happening in your brain. But first, I want to know what that exercise prescription is for you. Then I want to image your brain. Then I want to collect blood and see because I can see BDNF in your peripheral blood system, and I can see a lot of the other growth factors as well. Then we get down to the actual neurochemical pathway, and that is yet another way that we might be able to intervene. Does that give us some clues? Maybe we can go and explore what exercise is maximizing BDNF and enhance hippocampal function even more. So those are the steps in my personal research program. Behavior, we need the behavior first. Imaging and blood come next.
So how do people get involved, and how do we keep track of your research? I mean, obviously we will invite you back to Being Patient, but we also want to know how do we keep abreast of all of this? This is important information for everyone.
So I think the best way to keep abreast is to go to my website, wendysuzuki.com, very easy to remember. All of my talks, all invitations to studies, invitation to a new startup company that I'm developing will be there, and so that's the best way to keep abreast of all the things that I'm doing in my lab and my public speaking and classes that I might give in New York City or maybe your city. So that will all be on wendysuzuki.com.
Great. Thank you so much, Wendy, and especially for the research you're doing. I'm certainly someone who's incredibly interested in this. I thought of one more thing I wanted to ask. Yeah. Are you focused on a specific age group in your research?
Yes, my age group is baby boomers. So young baby boomers are 40s, 40 to 65, basically. Why? Because this is the age when the very, very first brain changes are starting to happen if you have dementia or Alzheimer's in your family history. And so this is a critical area in which to intervene. Other research focuses on university students because I have a lot of university students at my fingertips, but my main research demographic is 40 to 65.
And we all know that that is the time when you really need to improve your brain health to kick that can down the road.
Exactly.
When we start to accumulate plaques in our brain, up to 20 years or more before we see a symptom of Alzheimer's disease.
Absolutely. Yes.
Thank you so much, Wendy. Thanks for your time and for your knowledge. It's wonderful to see a neuroscientist really focusing on a lifestyle, something that we have control over and something we can change. So we thank you very much for your research.
Oh, thank you. Wonderful to speak to you today.
Great to talk to you.